Well, hello, this is Mrs. Sharp, and today we're going to talk about 3.5, which is talking about what a mole is. And I'm really excited to teach you about the mole. Mole is a big deal in chemistry. One thing that a mole is not is the thing on Cindy Crawford's face. She was a supermodel, maybe you don't remember her. The mole is not a cute little furry animal. The mole is a standard unit used to measure the amount of a substance. When we talked about the SI system and base units, we did talk about the mole, and the mole stands for molecular formula unit. And over time it got shortened and shortened and shortened until it ended up at mole. It relates the mass or volume of a sample to the number of atoms in it. Now here's the thing, it is not easy to measure the number of atoms in something. Atoms are too small to see, they're really, really tiny, they're always moving all over the place. But mass and volume of something is really easy to measure. Like the mass of a piece of lead, you can just stick on a scale. Or the volume of a liquid, you can pour in a graduated cylinder. So those things are really easy to measure. The mole is great because if we know those two things, we can figure out how many atoms are in the sample. 1 mole of atoms is 6.02 times 10 to the 23rd atoms. In fact, 1 mole of anything is 6.02 times 10 to the 23rd of whatever the smallest piece of that thing is. For example, 1 mole of pennies is 6.02 times 10 to the 23rd individual pennies. This number is called Avogadro's number, after Amadeus Avogadro, who was an Italian mathematician. Isn't he good looking? Oh my gosh. There he is. So he's responsible for that number. He did a lot of testing and mathematical calculations, and he's responsible for coming up with that. Sometimes I feel like you guys don't really understand what the mole is trying to do. It's just trying to take a really big number and make it more easy to work with. It's kind of like some other things you might know. Now, these don't have to go in your notes. I just saw in my help. Like 1 gross of something. I don't know if you've ever been somewhere where you've needed 1 gross. A gross is 144 of anything. So a gross of bananas is 144 bananas. A mole of bananas would be 6.02 times 10 to the 23rd bananas. A great gross is 12 gross. A ream of paper is 500 sheets. A mole of paper would be 6.02 times 10 to the 23rd sheets. 1 shake, that's an old English unit, and it's time. So like a shake of a lamb's tail is 10 nanoseconds. And 1 hogshead, this is a volume, is equal to 53 gallons. So all of these things are just another unit. For units that we have, it just makes it easier to work with. The same is true of the mole. Okay, up here on the screen, I have some conversion factors or equalities about the mole. So 1 mole is always equal to the 6.02, and you can see I added a 4th significant figure there. The 4th significant figure is 2. So 6.022 times 10 to the 23rd, what we call representative particles, which is the smallest piece. So for an element, that smallest piece are atoms. So 1 mole of an element is 6.02 times 10 to the 23rd atoms. But as soon as I talk about a compound, the smallest piece of a compound is not an atom. That can still be that compound. So like if you take water, for example, and water is H2O. So if I have a mole of H2O, the smallest piece of water that's still water is this 2 H's and an O. So we don't want to do atoms. We want to do molecules of water. If we wanted to do atoms, what would we have to do? Well, we'd have to multiply it because there's 3 atoms in this compound. We're not going to worry about that right now. But the smallest piece of this compound is a molecule, or sometimes they're called formula units. So remember, with these things we can write conversion factors. So we can either write 1 mole over 6.02 times 10 to the 23rd, what I'm going to call representative particles, or we can flip it over and write 6.02 times 10 to the 23rd representative particles, RPs, over 1 mole. So that's easy. We've worked with these conversion factors before. Just have to remember to identify your representative particle correctly. So let's do some and see if we can't figure that out. Here we go. Example 1. You have a sample of cobalt that contains 2.47 moles. How many atoms are in this sample? Well, let's look at this right here. Cobalt is an element. So the representative particle equals an atom. This question is asking us for atoms, so we're in good shape. We're going to start over here and we're going to say the number of atoms equals what? What is the number of atoms that we want? Well, we're always going to start with the number we're given in the problem. So we have 2.47 moles, and we abbreviate that with just an MOL. And I like to just put it over the number 1, no units, because it's just moles. It's not moles per something, it's just moles. But that helps me know that 2.47 is in the top. And now my conversion factor, remember, I'm just going to write these up here really quickly. I either have this, or I can flip that around and do that. Which one do I want to use in this case? My conversion factor has to go there. Well, remember from our talks before, we want this mole to be in the bottom. And that's so we can cancel it out. So this is the one where mole is in the bottom. So I'm going to take this conversion factor and I'm just going to recopy it right here. And when I do that, my moles cancel and I'm left with representative particles. Well, what are my representative particles in this case? Atoms. So I'm going to rewrite that as atoms. So that's the unit that I wanted my answer to be in. See, atoms, atoms, and it's not crossing off anywhere, so that's good. So the only thing left to do is put this in my calculator. So remember, anything on top we're going to multiply by, anything we're going to, in the bottom we're going to divide by. So what we have here is 2.47 times 6.02 times 10 to the 23rd divided by 1 times 1. Now to put this in your calculator, I need for you to hit 6.02 in your calculator. So you're going to punch in 6.02, and then you are going to hit second, the little blue button at the top left, and then you're going to find a double E that's written above the button that says x to the negative 1. So if you put in 6.02, hit second, find the button that says x to the negative 1. Right above it should be some blue double E's. Hit that. On your screen, you should see this, 6.02E. Now that's making your calculator think times 10 to the. So that is E. So then from there, all you need to do is type in 23, and your calculator is thinking 6.02 times 10 to the 23rd. So once you've got that in, multiply by 2.47, and you should get your answer. Times 6.02 E 23, and I get, okay, sig figs wise, we have 3. So I'm going to put in 1.4, and then it's 8, 6, so it's going to be 9, and times 10 to the 24th. And my units are atoms. Whew, let's try that. Let's try another one. This one says you have a sample of 5.89 times 10 to the 24th molecules of water. How many moles of water is this? Well, this time I want to know the moles of water, and I have molecules of water. These are the representative particles because water is a compound. So the representative particle are molecules. So that's good then. We're going to know when we're done the number of moles. And we're going to start with our given, which is 5.89 times 10 to the 24th molecules. And I'm going to put that over 1. Get this out of here. And then I need a conversion factor. And remember, I can choose 6.02 times 10 to the 23rd representative particles over 1 mole, or 1 mole over 6.02 times 10 to the 23rd representative particles. In this case, our representative particles are molecules. Which one do I want? I want this one, because that allows me to put my molecules in the bottom. Molecules will cancel, and I'm left with the unit mole, which is what I wanted. So, to put this in my calculator, I'm going to put this number times 1, so I can ignore it, divided by 1, so I can ignore it, divided by this number. So essentially, it's this number divided by this number. Anything in the top we multiply by, anything in the bottom we divide by. So we're going to take 5.89, and you're going to hit that double E button, and it should look like this in your calculator. Remember, it's right above the x minus 1, so second x minus 1, it should look like this. And you're going to divide it by 6.02, and you're going to hit again that double E button above the x minus 1, so second x minus 1, 23. So 5.89, second E, 24, divided by 6.02, E, 23. And that gives me 9 point, I'm going to have 3 sig figs, 9.784, so 9.78, and my unit is mole. Okay, let's do one more. This one's kind of a challenge. This is a compound, CO2. So what's the representative particle? Well, geez, I'm not even here, so I don't know what you said. But I hope you said it's a molecule, not an atom. So what we need to do first is find how many representative particles, and then I can figure out how many atoms based on how many molecules I have. So let's just find the number of molecules first, and then we'll tackle this atoms thing later. So we've got 1.43 moles, and we want to know how many molecules. So we've got 4.13 moles, and I'm going to put that over 1 just to keep my top and bottom straight. And remember my conversion factors. I've got this one, or I can switch those around. And this time, I want that one because it puts moles on the bottom. So I'm going to have 6.02 times 10 to the 23rd, in this case molecules, because that's my representative particle, over 1 mole. So moles cancel. Everything in the top we multiply by, everything in the bottom we divide by. I only have 1s in the bottom, so I can kind of just ignore those. So I'm going to have 4.13 times 6.02, and we're going to do that second x minus 1 thing, so 6.02 double E's, big E's. And that should give me my answer. So 4.13 times 6.02, hit the second button, and x minus 1. It should look like this, and then put in your 23 next to it. Hit enter. We should have 3 sig figs. I get 2.486, so 2.49 times 10 to the 24th molecules. Okay, now look at CO2. In 1 molecule of CO2, How many atoms are there? Well, there's 1 carbon and there's 2 oxygens. So there's 3 atoms total. So what do I need to do to this number? This is a molecule. There's 3 times as many atoms, so I need to multiply this number by 3. And if I do that, I get 7.46 times 10 to the 24th atoms. 3 times as many atoms as molecules. Just like in one molecule, there's 3 atoms. So this number should get bigger. Okay, I know that this is not easy to do, especially with me not being here, but I want you to try some. So please try them. Try them, even if you're completely wrong. Remember what we talked about last week. It's hard for you to know what you're doing wrong if you don't even try it. So please try it. I will be seeing you tomorrow, and we can go through, what you're having a hard time with, but give it a try. All right. Have a good day. I will see you tomorrow. Goodbye.